Bismillahirrahmanirrahim. Now I'd like to do some examples using the normal model. Okay, so these are some examples of probability. BIL, probability. Now, after all, this is a probability histogram, so to speak. This was extrapolation of probability. So probability using normal model. Okay. Now, if you recall, since this is a probability distribution here, that means the area under the curve is the sum of all probabilities. The area under the curve is 1. Okay. Now, so probability using the normal model. Okay. So here are the questions actually from the textbook. Okay. Now, the question says, okay, in a normal distribution that has a mean of this, okay, and a standard deviation of that, okay, what's the probability that of a randomly selected? So, if you're selecting some random data point, what's the probability of that random point being between the mean and 2 standard deviation away? Okay, so what they're doing here, they're saying is they're going to pick a point from anywhere randomly from the range, and what's the probability that that point will be between these 2 values? Okay, all right, so that's written as this. So what's the probability that if you pick any point from the data set, actually the data set, remember the data, this is the data set, it starts from, that's the range. Okay, those are all the data values from here to here, from the beginning to end. Okay, what's the probability that if you pick any point in the data set, that it would be between or less than or equal to the mean, and between that and 2 standard deviations from the mean? Okay, so what's the probability that it will be between this and this? So that's the question. Okay, so the probability of finding any data point, this is like geometrical probability, if you recall, is the area of the region divided by the whole area. The whole area is 1 because that's the probability 1. So the probability of finding between this and this is going to be this piece plus this piece. Okay, that's going to be the probability of those two, and that's going to be, this is percentages, and the probability is going to be 0.135 plus 0.34. Okay, those are the probabilities, and if you add this up and this up, if you add those two up, okay, the probability of that would be 0.475 or 47.5%. So it's 47.5% chance that that data would be in these two. Okay, so you just add this up, which is 13.5%, and you add this up, which is 34%, to give you the probability of the data landing in that range. Okay, so that's a probability. Now I like to do another example from the book. Okay, and we're going to start all over. We're going to try to do this again because it's that important. Okay, so example number 2 in the book says the blood cholesterol readings for a group of women. So they did a study, okay, on a group of women. Okay, and it says the data gathered follows a normal distribution. That means you can apply the empirical rule in this case. Unless you're told that the data follows the normal distribution, you cannot apply the empirical rule. You cannot apply all the fancy stuff that we learned. But here you're told that the data collected follows the empirical rule. So they did a whole bunch of blood tests in women, okay, and they checked their cholesterol levels, okay, and the cholesterol level, the mean value, this is a symbol for mean, okay, which is average, okay, and the mean value was 172 milligrams per deciliter, which is not very good actually. That's not a good cholesterol level. And a standard deviation, so as I said, mean has various different symbols. I guess there are very different ways to be mean. mu is another symbol here like this, and here's another symbol, mu for mean, mu. I just combined the two to make it look like this is not an ordered pair. I don't want you to get the wrong impression. These are just symbols for mean. These are just symbols for mean. So they did all these women. They figured out the cholesterol level, and they're all pretty bad. The mean was 172. Okay, and then they said the standard deviation, or how far away from the mean they were, was 14. The standard deviation is the symbol is sigma here. Okay, that's the standard deviation. Here's my symbol. Standard deviation here was 14 milligrams per deciliter. Okay, so we know the mean and we know the standard deviation. See, the power of this of the empirical rule is that you're just given two pieces of information, and you can actually gather a lot of information just given those two pieces of information. So what I'm going to do is I'm going to construct a normal curve, a hypothetical normal curve based on this two information. Okay, in this case. Now, what was this one side? I guess for right hand, it's not going to be the best. All right, let's try to do it one more time. Okay, so here it is. My goodness sake. Okay, here we go. All right, so here's, now pretend this is the data. So we are told that it follows the rules, it follows normal distribution, so we can hypothetically construct this. And we're told that the mean here, okay, we're told that the mean was 172, okay? Now, we can construct, using just this, our model, okay? So remember, if you just cut off the little tails, because, you know, they cut that off, cut out the little tails, snip them off, that's 2.5% of the data, and it's 2.5% of the data. And then you remember, you cut this into two halves, okay? You make lines that go up like this. You make lines that go up like this. After a while, this becomes quite fun. All right, maybe you could do it like this. Okay, now this is going to be 68% of the data, 68, 95, and 99.7 if you recall. And then you go up like this, and you go up like this, like football field goalpost. Okay, and that's going to contain 95% of the data. Okay, so from here to here is one standard deviation, and from here to here another standard deviation, one standard deviation, one standard deviation, like this, right? Okay, so this is the mean, okay? And we're told the standard deviation is 14. So the value of x over here is going to be one standard deviation away. It's going to be 172 plus 14, see? All right? So that's going to be 186. So the value of x at this point would be 186. And another standard deviation from this would be two standard deviations, 200. That's another 14. So we told the standard deviation is 14. That means each of these little cuts, okay, our knife is going to cut 14, 14, like that, okay? That's what we were told. In values, not percentages, okay? So this value is 172. This value is 186. This value is 200. Now going backwards, you subtract 14. This is one standard deviation, one less than that. So this is going to be like 158. Okay, 172 minus 14. And another standard deviation would be 144. So this value corresponds to 144. Okay, so we got that. So we made this graph based on this pieces of information. Okay, now the question is about what percent of the women have readings between 158 and 186. So the question is about what percentage of women have readings between this and this. Now when we did this, okay, all right, we said, okay, so this is smack in the middle. This is the 50th percentile. Okay, we said this is 34%, this is 34%, and this is like 13.5%, and this is 13.5%. Okay, we got that. So the question here was what percentage of the women are between these two values here. That's this and this, okay? And that is going to be this part of the, so that many percentage of women are between this. Was a pretty easy question in a way. The answer is what percentage of women are between this and this? The answer is 34 plus 34, and that is 68%. So approximately 68%, because these numbers are rounded off. You know, statisticians probably go off to like 20 decimal places afterwards. But anyways, for rounded off, 68% of the women have values, have cholesterol levels between, that's a good number, 158 and 186. Okay, they need to work at it. Okay, now number 2, B. The question says, a reading less than 158 is less than are considered desirable. So this way, you like to have cholesterol levels that are low. Below 158 is good. So you want the cholesterol level to be 158 or below, they say. About what percent of the readings are desirable? What percentage of the readings are desirable? How, in other words, what percentage of the women lie below over here? Okay, that's the percentile. Okay, so that percentile, if you recall, goes here as a 0 percentile. So this is 2.5 percentile, and 13.5 plus 2.5 gives 16 percentile, and that's 58th percentile, and this is 84 percentile, plus this is 97.5 percentile. So from this, it becomes apparent that 16% of the women are below 158, okay? So that's this plus this, okay? So 16% of the women have values less than, have cholesterol less than 158 milligrams per deciliter, okay? So only 16% of the women are in desirable range. The rest of them, okay, that's 100, 100 minus 16%, okay? That's 84% of the women are not at a desirable level, right? 84% of the women are not at a desirable level. So they are the ones who have to work on their cholesterol. Okay? So this is just example of how to use some of the basic elements of the normal curve. Now you should be able to generate a normal curve given just the mean and the standard deviation. So you can put the mean where it is, and you can generate the values at each standard deviation. And you should be able to, as we did over here, percentile and the z-score of 0, negative 1, and negative 2 here, z-score 1 and 2 over here, right? So a z-score of negative 1 or less is considered desirable in this case, right? Okay, this was just an example. Inshallah, after a brief pause, we'll do some more examples of like this. Until then, as-salatu was-salamu ala rasulillah wa ala alihi wa sahbihi. Assalamu alaikum.